Today's video is about the general conic form of hyperbolas. First, we're going to talk about what a hyperbola is. It's the set of all points in a plane such that the difference of the distances to two fixed points called the foci is a given constant. Every conic section can be written of the following form: ax squared plus by squared plus cx plus dy plus e equals 0. If your x squared and y squared term have different signs, no matter if a and b are equal or not, then we have a hyperbola. And we have two types of hyperbolas. We have one where the hyperbola opens left and right, and that's based off the x squared term being over the a squared term. You also have a hyperbola that opens up and down, and that's due to the fact that the y squared term is over the a squared term. So notice here that the numerators will switch based on the location of a. And so wherever the term that's positive, that's the square term that's positive, is what we're looking for. It will tell us if the parabola opens left or right or up and down. And so once we get the standard form of a hyperbola that you see here on the screen, then we need to describe the hyperbola. We need four things to describe the hyperbola. We need the coordinates of the center. We need the coordinates of the vertices. We need the coordinates of the focus points, of the foci. And then we need the equations of the slant asymptotes. And so here's a formula that will relate C, which is going to be a squared plus b squared. So let's do some examples. So here's our equation here that's given in general conic form. So what we want to do is write it in standard form by, again, grouping your x and y terms together. So we have 11x squared minus 22x plus negative 4y squared minus 16y equals positive 49. Now we need to factor out our a and b. So we factor out the 11 here, we get x squared minus 2x plus blank minus 4, which is the b term we're going to factor out, which is negative 4. That's y squared plus 4y plus blank equals 49 plus 11 times blank minus 4 times blank. And we're going to complete the square by taking half of our middle terms and squaring them, and then writing them in the blank on each side of the equation. So here, when we complete the square, here, taking half of negative 2, which is negative 1, and squaring it, that's positive 1 here and positive 1 here. Taking half of our middle term here, the 4, that's 2, and then squared, that's 4 here. So now we have 11. So we're going to factor and simplify. We have 11 times x minus 1 squared minus 4 times y plus 2 squared equals, and we're going to add these together. So we're going to have 49 plus 11 minus 16, that gives us 44. Okay, so now after we simplify, we need this to be a 1, so we need to divide both sides by 44. When we do that, we get x minus 1 squared over 4 minus y plus 2 squared over 11 equals 1. All right, so now we have our, sorry about that. So we have now our equation in standard form. Okay, we have our equation in standard form. So now we need to find our A, B, and C. So our A is square root of 4, which is 2. Our B is square root of 11. And C is going to be 4 plus square root of 4 plus 11. So C is square root of 15. Now we need to talk about how our parabola opens. So if you notice that the square term that's positive is x, so that means our parabola opens left and right. So here are our vertices here, our centers here, vertices are here and here. Our focus point is here and here. And then we have our asymptotes. We have 2 slant asymptotes. One has a negative slope that goes through the center, and one has a positive slope that goes through the center. So that is what our hyperbola looks like. Let me put the other vertices here. So you have a vertex there and a vertex there, but these 2 vertices are not on the hyperbola. So you got 2 vertices that are on the parabola, and then the other 2 vertices are not on the parabola. And then, of course, again, your focus points are inside the hyperbola. So we're ready to describe this hyperbola. So we have a hyperbola with center 1, -2, vertices. So what we're going to do, because the parabola opens left and right, we're going to add a to the x-coordinate of the center, and that gives us 3, -2. Then we're going to subtract a from the x-coordinate of the center, which is -1, -2. Then we're going to add b to the y-coordinate of the center, and that gives us 1, -2 plus square root of 11. And we're going to subtract the b from the y-coordinate of the center, which gives us the other vertex, 1, -2 minus square root of 11. Then our focus points, remember they're always C units from the center. So we're going to add C to the x-coordinate of the center. So that's 1 plus square root of 15, -2. And then we're going to subtract C from the x-coordinate of the center, which is 1 minus square root of 15, -2. And then we have our asymptotes. So our asymptotes, we are going to write it in point slope form here. It's going to be, so we always use the center for the point, and then the slope is always b over a. The slope is plus or minus b over a. So the equation, well, one of our equations is y plus 2 equals square root of 11 over 2x minus 1. And then the other asymptote is y plus 2 equals negative square root of 11 over 2 times x minus 1. That is how we describe our hyperbola. All right, here's our second example. We're going to, again, group our terms together. So we're going to group our negative x squared terms together. We're going to group our y squared terms together. And we're going to subtract 19. And then we're going to factor out our a and b from each expression. So we're going to factor out -1 here. So that's -1 times x squared minus 2x plus blank plus 4 times y squared plus 6y plus blank equals -19 minus 1 times blank plus 4 times blank. And we're going to complete the square, take half of -2, which is -1, and then square, that's +1. Take half of 6, which is 3, squared is 9. Goes in. Then we're going to go ahead and simplify and factor. So -1 times x plus 1 squared plus 4 times y plus 3 squared equals. And what we want to do is simplify that. So we got -19 minus 1 plus 36. And that's 16. Then after that, we want to divide by 16 because we need the right-hand side of the equation to be 1. So we have -x plus 1 squared. Actually, what I want to do, when I divide, I'm going to do two things. Because this is negative, I'm going to switch these two terms. So I'm going to write the y term first. So that's going to be y plus 3 squared over 4. So I just move this in front because it's positive, and move this behind it, which is negative. So x plus 1 squared over 16 equals 1. So now I have the form I need. So now my a is square root of 4, which is 2. My b is square root of 16, which is 4. And my c is square root of 4 plus 16, which is square root of 20. And if you want to actually reduce that, that's 2 square root of 5. So now I'm ready to describe figure out what my hyperbola looks like and describe it. So because y squared is leading here and it's positive, it opens up and down. Hyperbola opens up and down. So here are my vertex. So my vertex is there, my vertex is there, my center is there. Here my other vertex there and there. My focus is here and my focus is here. And then we have our asymptotes, one with a negative slope that goes through the center. I know my drawing is a little off. My drawing is a little off, just bear with me. Let's just say it does that there. Okay, and then the other one is a slant asymptote, and it goes through, and also go through the center like that. So that's just a rough sketch. So I'll have all the things I need. So let's describe the hyperbola. So we have a hyperbola with center -3, -1, vertices, because, and I got to be careful again what I add and subtract to which part of the center. So the vertices, because this opens up and down, I'm going to add a to the y coordinate of the center. So I have -3, 1. Then I'm going to subtract a from the y coordinate of the center, which gives me -3, -3. Then I'm going to add b to the x coordinate of the center, which is 1, -1. And then subtract b from the x coordinate of the center, which is -7, -1. And then my focus, I'm going to add c to my y coordinate of the center, so -3, -1, plus 2 square root of 5, and then subtract c from the y coordinate of the center, which is negative 3 minus 1 minus 2 square root of 5. And then finally, I'm going to write my asymptotes. Always remind yourself that the slope is always plus or minus b over a. So one of my asymptotes is y plus 1 equals 4 over 2 times x plus 3. And the other one is y plus 1 equals negative 4 over 2 times x plus 3. And of course, that will simplify to negative 2. Negative 2 when you reduce the fraction. But I just keep the fractions like that so you can see how it's written. Here's our last example. So just like before, we're going to group our x terms together and our y terms together. And then this constant we're going to add to the other side. Then again, I factor out my a and b. And you're going to notice here I only have one blank. That's because this x squared term is all that's here. So we don't have to worry about trying to complete the square on x squared because it's already squared. So we're good there. So when we complete the square, we're going to get 4 here and 4 here. And once we do that, we're going to simplify. So we have 25 x squared minus 4 times y minus 2 squared equals 100. Then we're going to divide by 100. That gives us x squared over 4 minus y minus 2 squared over 25 equals 1. And so our a is square root of 4. So that's 2. Our b is square root of 25, which is 5. And our c is square root of 4 plus 25, which is c equals square root of 29. How do I know a was 4? Because again, the term that's positive, the square term that's positive is where your a is located. So here, our a squared is 4 and our b squared is 25. And because of that, we know that our parabola has to open left and right. So our center's here, a vertex there, vertex there, focus point there, focus point there. Slant asymptote always goes through the center. One that has a negative slope. The other one has a positive slope. And so now we're ready to write or describe the hyperbola. So we have a hyperbola with center, hyperbola with center 0, 2, vertices. Again, be careful on who you add and subtract a from, and be careful who you add and subtract b from. Look at your parabola; it's open left and right. So a we have to add a to x of the center, which is 2, 2. We're also going to subtract a from the center. Subtract a from the x coordinate of the center, which is negative 2, 2. Then we're going to add b to the y-coordinate of the center, which is 0, 7, and subtract b from the y-coordinate of the center, which is 0, negative 3. And then our focus, okay, our focus points, we're going to add c to the x-coordinate of the center, which is square root of 29, comma 2, and subtract c from the x-coordinate of the center, which is negative square root of 29, 2. And then we write our asymptotes in point slope form. Remember, your slope is always plus or minus b over a. So one of your lines is going to be y minus 2 equals b over a, which is negative 5 over 2, negative 5 over 2 x minus 0, and the other one is y minus 2 equals 5 over 2 x minus 0. That is the description of the hyperbola. And that concludes this video on the general conic form of hyperbolas. If you have any questions, comments, or concerns, please feel free